Okay, so before we start coding, we should do some pseudocode to think about what we're doing. So what is the problem? So the first one I want to start off is pretty simple. We've done this program before, but we didn't have decisions to make with it. And so we've taken in data from the user. We know how to do that. We know how to print it out. We know how to calculate it, but we haven't made any decisions. And so what I want to do is I want to take in data from the user. I want to take in two numbers, and I want to divide those two numbers and print the result. But we knew how to do this before we started chapter 4. So what are we doing different now? Well, what I'd like to do is, we know that we can't divide by 0. It's a problem, right? So we need the computer to decide, if we're dividing by 0, what should we do instead of dividing? And so that's what I'd like to do with this, is I'd like to open up Notepad here. And I'd like to think about this problem that we have. And so we are going to start off with some pseudocode before we start coding, because it's always good to think about the problem. So we need two numbers to do this, right? And this isn't code yet, but we're just thinking about what we need. So we need to input a number 1, and we need to input a number 2. Okay. Then once we have those two numbers saved, we need to decide if that second number is 0, because if that second number is 0, we can't divide, right? So we need to use a decision. Say if this is number 2, it doesn't matter what number 1 is, because you could take 0 divided by a number, but a number divided by 0 causes problems. So we will say if number 2 is 0, then we want to print error, okay? And I like to indent that in my pseudocode so you can see that that is part of the if. Okay. Now what if it's not 0? Well, then we can go ahead and divide, right? So we will say else, we'll print, what is number 1 divided by number 2? Okay. And let's go ahead and save this. So we have this. I'll put it on my desktop, but if you have a folder for all of this, go ahead and put it in your folder so you have your examples. And so we will call this maybe divide by 0, or you could just do div 0. Whatever helps you remember what it is when you look back at your examples, because this is for you to look back later. Does everybody understand that pseudocode so far? Pretty easy. I know we've done this program before without the conditional. So we know how to take in the data and divide it and print it, but it's just the decision that we're looking at. And that isn't code yet, but we're thinking about the problem before we code. So if I put this over here and I go back, so I want to go back to my C++ shell here. Okay. And go ahead and put your name at the top. And today is the 26th. Okay. And then we're going to put just a basic description about the program. So what are we trying to do? Divide by 0, just something simple that reminds you what the program is about. Okay, so we need to do input for number 1 and number 2. So hopefully everybody is pretty clear on how we do the input. So we can't do input before we tell the user what we're trying to take in, because they would just get a blinky cursor and they wouldn't know what to type in. So we have to tell them what they're supposed to be typing in. So we would say, enter a number. Whatever you think would be a good description about what they're supposed to do. And if you want that number to be on the next line, remember you put end line on there, end L, otherwise just leave it because it'll be on the same line. I think the same line is fine. And then we need to take in the data. Okay, so at this point, hopefully you realize, okay, I need to have a variable, right? So you need to make some decisions. You need to say, what type of variable do I have? Okay, do you want to take in doubles? Do you want to take in integers? What type of data do you have? And so we are going to go back up here and we'll do integers for this. So we are going to say int, and we could say num1, for example. Okay. And we are going to say num1 here. Okay. And then we're repeating the same thing for num2. We're taking in another number. So we are going to copy this. And you could just say enter a number, or you could say enter another number if you want to, whatever you think looks good. And then we need to add this to be num2. And so far, this is review of what we've already done in the past. Everybody okay to this point? Now, I should probably test my program to make sure that that works so far, because I don't want to get too far along and realize that I've typed a syntax error and it's not going to work. So we're going to go ahead and run it and make sure that we get the input so we can enter two numbers. Now, of course, we haven't put the logic to divide it yet and see the result, but this is where we were talking about we need to add a decision. So if we see in our pseudocode, we've handled these first two steps in putting the two numbers, but we need to handle this part. And this is what we talked about the other day. And so does anybody remember how we can't use the word is, okay? So we can start off with if, right? We could say if, and we can use num. Now it has to be num2. Num1 doesn't matter. How do we say if num2 is 0? Does anybody remember how to say that?
Exclamation.
Oh, that's a good guess. So that actually changes it to an opposite of. But that's on the right track. Yes. So it's double equals. Why can't we use just 1 equals? Does anybody remember why we can't use 1 equal? Yes, exactly. So if you put 1 equals like this, so number 2 equals 0 like this, that looks like, you know, pretty logical. I would think that that would check to see if it's 0, but that actually makes the number 2 variable 0 instead of asking, is it 0? So it's always going to be true because it's not a question. It's just assigning it the value of 0. It's not asking, is it 0? So it will let you do that, but it'll always be true because it's not a question. And so in order for it to be a question of, is it true? You have to put 2 equals. Okay. And they can't have a space between the 2 equals or it won't work. Okay, so if number 2 is 0, and we should indent this because that makes it easier to read. It will still work if you don't indent it, but then when someone's looking at your code, they won't know that that's part of the if statement if you don't indent it. So indentation is important. Some languages it's required, like Python, for example. If you don't indent it, it doesn't go with the if, but C++, if you don't indent it, it's still included, but it's hard to read. And so we should do that. Now, we are only going to have one line under this if, so it's not required that we put the curly braces, but if you like to have them on all of your if-else blocks, you can put them if you want, but we only have one line, so it's okay. So we can't write the word print, but this is where we would do a cout statement. Okay, so cout, and we would say error. Now, if you want to get more descriptive than that, if you'd like to say cannot divide by 0, you can do that. We'll say error. Okay. Now, if you don't have a number that is equal to 0, then that would be the opposite. Now, you could do what you were saying before with exclamation point. You could say if number 2 does not equal 0, like you were saying with exclamation point, and then actually do the division there. So actually you were on the right track. You could do it that way. If you were thinking about that logically, some people like to handle the not first and then go the opposite way. So yes, you could say if number 2 does not equal 0 and do the division right there. And then the other one would mean that it was okay or it wasn't okay. So we would put the arrow on the other way. We would flip them. Instead of saying if number equals 0, error, we would say if number does not equal 0, divide, and then else error. We would just do the opposite. So that's fine to do it that way. We can flip it so you can see that if you want once we get this. Okay, so the other option we have is that it's okay. So else would mean that it's okay. So we need to divide. So we can actually just do it right in the cout statement if you want to. If you wanted to divide it, save it in a variable, then print it, you can do that as well. But since we're just doing a simple calculation, we could just do it right inside of the cout. So you can put a label that says quotient so we know what we are printing. And then we can actually divide the two numbers. So we need number 1 divided by number 2. Now, does anybody know of a problem we might have with dividing 2 integers? What will we get as an answer if we divide 2 integers? We want to get a decimal, but if we have 2 integers, we will get a whole number. Good, we'll get an integer, yes. So if you have 2 integers, you get an integer. So the problem is if I said 3 divided by 4, I would get 0 as an answer because it's 0.75, but It's not going to tell us that because they're two integers. So you would get 0, it would just chop the ending off. If that's what you want, that's fine. If that's what your program was intended to do. But if you wanted the decimal answer, you have two options. Does anybody know what one of those options is?
Casting, not
Yeah.
static cast.
Yes, you can cast. Yes, I love that. Okay, casting is my favorite way to do it. But you can also change the data types up there. So instead of int, you could change them both to double. But you may not want to do that. Let's say that you were actually wanting them to enter an integer. I think casting is better if you were intending them to enter integers, because if you do change the data types to double, then they can enter decimals. So it depends on if you're wanting them to enter integers or doubles, and you can decide that. But if you don't want them to enter decimals when you're doing it, then casting would be the option that we would have to go with. And so you can actually just change the casting right here in the printout. And so we put static. I'm going to move this over so you can see. Okay, so static cast. And then we are going to see what data type we're casting to. So what data type are we casting to? What are we changing it to, do you think? What's the decimal data type? Double, good. Yeah. We could use float or double. Either would work. Put that over there so that you can see this. Okay. And then now I think it looks good, but I won't know until I run it. And so if I run it, we'll see, does that work? Okay. Oh, so I have something here. I do. Static cast double. Oh, I have to put, see, it's always good to test, right? I'm going to put that in parentheses so it casts that first number to a double. And then I think I have it after that. Okay, so if I don't put that number 1 in parentheses, then it doesn't know what to cast because it'll do the division and then it'll try to cast it. So if you put that in parentheses, remember parentheses happen first. So it'll cast that number. It changes number 1 to be a double decimal number, and then it'll do the division. If one of those numbers is a decimal, then you get a decimal answer. Only one of them has to be a decimal for you to get a decimal. If both are whole numbers, then you get a whole number. So that changes number 1 to be a double, which is a decimal, makes the division so you get a decimal answer. Okay, so if I type in 3 divided by 4, I should get 0.75. And just because I didn't run it before, let me show you. Don't change yours, just watch mine. Just so you can see what would have happened had I done 3 and 4 before. I probably should have ran that before and showed you. But we talked about this before, so hopefully this is review. And so if I don't have it casted, then I don't get the decimal number. Now, that wasn't the part that I was mainly focused on. I wanted to focus on the conditional. So we were talking about that. It will do the division as long as you don't try to divide by 0. So I didn't test that part yet. I tested it with 2 numbers that aren't 0. So let me try to take 3 divided by 0 this time. And it should give you error. So if you do the second number is not 0, you should get an answer, and hopefully it's the right answer. Double check that. And then if you do it again, try 0 as your second number, and it should tell you have an error. So always run your program more than one time, making sure that your decisions are actually working. Does anybody have any questions about this? Very good. If your code is working, please copy your code and paste it into that pseudocode text file that we have, because this will be a good example for you to use later on. And so the more examples you have, the better. So once your code is working, go ahead and paste it in with the pseudocode and save it. I already gave mine a file name, but if you didn't give yours a file name and save it, make sure you save it so you have it. And hopefully this will be a good example. If you need to cast, you can look that up. And if you need to do a basic if else, this is a good example of that. And then we're going to start another program. But before we do that, Is everybody good? All right. So we'll open up a new tab here and we'll go ahead and leave our basic template here. So we can erase this. Everybody have this? Okay. We can erase this and we can erase what the name of the program is and just leave our basic shell. And we'll start a new tab so we can do pseudocode for our next program. So this one we're going to do odd even. So we're going to figure out, is a number even or odd? Okay. So we could look at it and determine and just, decide which one to print. But we want the computer to make the decision. So the computer is going to decide whether it should print even or odd. Okay. So we have to think about what would the pseudocode for that first be. Okay. So if I'm looking for a number to determine if it's even or odd, I first need to have a number, right? So first step, input number. Okay. Then does anybody remember how we can decide if a number is even?
Modulus.
Modulus, perfect. Okay. So let's see if that number modulus what? Do you know?
2.
2, good. And then what I say modulus 2, does anybody know the rest? If the remainder is, I could just put if the remainder is, how do we know it's even if the remainder is what? 0, good. We'll just put is there for now and worry about the actual code when we get there. So if you divide by 2 and the remainder is 0, so remember modulus means remainder. So if we divide by 2 and the remainder is 0, then we know that it's even. So we can print even. Well, if it's not even, it must be odd, right? So the other option would be print odd. Notice with the else, we don't have a condition because it's either going to be one or the other. So if it's not the if, it has to be the else. Okay? If it is the if, then it won't be the else. So only one of them can happen. And so the else never gets a condition because it's default if the other one doesn't happen. And it doesn't even want the parentheses there. Okay. So let's save this. And we'll call this even odd. Again, whatever name is going to help you remember what it is when you're looking at your examples. Okay. And then I can go over and I can add my comments. And you can put a question mark. We're having the program determine is the number even or odd. So first thing, let's get a number. Okay. So our pseudocode says, let's get a number, input a number. So give directions for getting the number because otherwise they won't know what to type. So we need a cout statement that says enter. I can't type it, a number. Okay, oops. And then cin, and this is where we get to the point of I don't have a variable, right? I need to have a variable because I can't just put one in there because C++ doesn't know what that is. It needs to know what's the name of your variable, what's the data type, and what value are you putting in there. And so I need to think of a good name for my number. Could go with number, I could go with num, I could go with n. Any of those are good choices. So we're going to do an integer. So int, we'll just put num for number. And then you can come back down here and do num. Now we could run it to make sure that works and we're able to input a number. So it won't do anything except enter the number, but at least we know that part works. Now the next step is our conditional. So this is the part that's new. So we can look at our pseudocode and we can say, okay, well, I'm going to start with an if, and I need to do if the number modulus 2 is 0. Okay, so we'll go back over here, say if. Now, when you do an if in code, you have to put parentheses. Okay, so if whatever your variable name is. Now, over here, I said number, but over here, I said num. So your pseudocode is just a reference to help you. You don't have to get the exact names of the variables on there. If you want to, you can. Saves you a little less typing if you don't have to write out the word number all the time. But if you want to write number or you want to change that to num, that's fine. Okay, so if num modulus 2, now that part is good. We're good. But again, how do we do? Check to see if something's equal to 0. Equal, that's right. Okay. Okay, and then we're going to see out, and we're going to just print even. And then otherwise, we can just print odd. Look good? Makes sense? I'm going to come back to that not. I forgot to do it in the last one, but I'm going to do it on this one. Okay, so let's run it and see if it works. So enter a number 3, odd. Okay. Enter a number 2, even. Try it a couple times, make sure it's working. Does it make sense to everybody? Is everybody okay with this? Okay. Now we were talking before about the not. You can flip your way of thinking and you can leave it like this. This is fine. So if you like it this way and this makes sense to you, go ahead and copy it, put it over into your pseudocode and save it. So you have it. If you have a working version, save it. Okay. Now, if you want to adjust this, you can, or you can just watch and see what happens. But if you wanted to say, flip this and say not equal to 0, you would just flip your logic. As we were talking about with the negation, if you put the exclamation point, you're just saying the opposite of it. So really, that should still work. It's just flipping the logic. So it still works. It's just a different way of thinking about it. If you want to start with, what if it's not equal to this? You can do that. Now that we're on decisions, programs will start looking different from everyone's because you will think about it differently than someone else thinks about it. And there's so many different ways. I mean, this one's pretty basic, so there's only 2 ways you can do it. But as we get more and more, and we get ranges and everything, we will be able to write it so many different ways. But this is another way to think about it. And if that makes more sense to you, it's fine to do it that way. So everybody see the difference? There's a shortcut. I don't use it that often. It only works for if else, but we talked about it the other day. And so just to make it easier, because I think this will probably make it easier, I'm going to put this back just so you have a reference to look at in case you didn't change yours. I want you to, I'm going to minimize that for a second. I want to go back to the slides from the other day. And I want you to see if you can do this conditional operator on that if else. So using this as a reference from the other day, see if you can modify this if else to use this conditional operator. And you may never use this. You may like it the way that you do with the if else. It may make more sense to you. A lot of times it's a little easier to read that way, but you may see other people code with a conditional operator. And a lot of times you're not the only one programming, you're working with someone else. And so someone else may use that and you should know what it is and how to use it. So even though you may not code that way, somebody else might. So it's always good to make sure that we're aware of all the different possibilities. Okay, so see if you can take what I've highlighted in there and adjust it to be the conditional operator. And then we'll do it together and make sure everybody's good. So for this part, for testing purposes, what we'll do is I will just say rewrite using conditional operator. And what you can do for testing, you can comment this part out. So you can put a comment around this part so that you're not completely deleting it. And then it should just be one line of code right where I have my cursor. And so This part, if you just put slash asterisk here and asterisk slash here, will be a comment, so it's not going to register when you're running your program. But then you can just go take out that comment later if you wanted to use that one instead. But for testing purposes, let's take it out for now so we can try to restructure it, and then we will rewrite that. So take just a minute or so to try to do that. All right. Little behind on the video, but all we did was enter our number so far and go through, so should be okay, hopefully, if you're reviewing this later. Okay, so we are going to print neutral here. Okay. And so, again, you could have started this as your if up here instead of starting with greater than 0. That'd be fine. You could also have started with negative, but it doesn't really matter. You just have to make sure you get all of the different cases, whichever one makes sense to you to start with. It's fine. So we do want them to be connected, though. Instead of doing it just as an if, we want it to be an else if, because what that means is it tests the first one, and if that doesn't happen, it goes and tests the second one, and if that doesn't happen, it automatically does the else. If you do them as separate ifs, then it can match all of the different ifs, and it doesn't, in the first case, it doesn't kick it to the else because it doesn't match up with it. But this tells it that if this is false, go here. If that's false, go here. Okay? If this is true, it doesn't do any of them. But if this were a separate if, it would check that as well because it's separate, it's not connected. So else if means connected to the if. A separate if means not connected. Does everybody see the difference? That makes sense? So let's test it. Make sure it works. So again, I can just test some numbers, make sure that that still works. I tested those before though, so let's do 0. So it should say neutral. Okay, did everybody's work? Does anybody have any questions? Okay, now that we have a finished product, go ahead and save over here. You can add to your pseudocode too. So else if number is 0, print neutral. And then go ahead and save that. Okay. All right, we get a little more complicated. Is everybody okay so far? All right, we're working our way up there. So let's go ahead and open another tab. Let's clear this out so we can do another program. Okay, and then we are going to write pseudocode. And on this one, we're going to determine what letter grade somebody gets. So if you have a score, a test score, what letter grade would that equate to? Okay, so over here you can write determine letter grade. And over here, in order to determine a letter grade, we do need to input a score, a test score. So we'll say input score. Okay, and then we need to decide what would be, now you can start with F or you can start with A. Doesn't matter. So we'll try A. We'll try starting with A first. So how would you know it's an A? What's an A? What test score is an A? 90 and above. Good. I like how you said 90 or above. Okay. So if we do if the score, now when you're doing 90 or above, we would do greater than 90 to just do anything above 90. But how do we include 90 as well? What's the greater than and then equal to? Yeah, greater than equal to 90. That means 90 and everything above. But if you just do greater than 90, that doesn't include 90. Okay. Then we can just print A. Now we can go through this the same way. Now, from the last program we did, we learned that we can connect this to the if by using what? Else if. Good. So we will do else if, because if you don't have an A, maybe you have a B. And if you don't have a B, you have a C. But you shouldn't have an A, B, you shouldn't have multiple grades. And what happens if you don't connect them is if we say that a B is a score of greater than equal to 80, if we keep going with this, if you don't connect those two, you'll have a problem, because if you did if score is greater than equal to 90, and then you did if score is greater than equal to 80, well, guess what? What if you get 100? You get an A and a B because you're greater than both of those. It would match both of those. So if you do if instead of else if for the second one, that causes it to match both of them instead of just matching one. Does everybody understand the difference between if, and if, else if? If, else if means they're connected. So it can only, and I should have put if, the word if there. It can only match one of them. If it matches the first one, it doesn't go to test the second one. But if you do if, it can match both of them, depending on how you write it. Okay, so we need to be careful. So then we can print B. And there are some cases where they're completely separate ideas that you're talking about, and so they would be completely separate ifs. But in this case, you only get one letter grade, so they're all connected. So it should only give you one result, and so they should all be connected to each other. So we do else if for each option that we have. And so we can just go down through 70 is a C, and 60 is a D. You have to be very careful when you're doing it in code that you do the greater than equal to without a space between them, and you don't put the equal sign first. It has to be the greater sign then the equal sign. Otherwise, it does not work. So C++ is very picky about the order in which we do things. Now, we could continue with this and say greater than equal to 0 as an F, but the only other option left is an F. So we could just put else F. So really, it's up to you in this case. So we could do else print F. Does everybody understand that logic? That makes sense? Okay, so let's save it. And we'll call it grades. Again, whatever makes sense to you, because you're going to be using this as a reference later. So when you think about that grades program, you remember what you did in there, so you can look up, this is the one where I did this, and use it as a reference. Okay, so let's get to coding. So first we have to input a score. Okay, so hopefully you know how to do this pretty easy. So we are going to, we know we need a variable because we keep going through this when we get to that point where we need a variable. I can call this one score just to match my pseudocode so I don't get confused like I did before on what my name was. And so I'll just go with score. So, okay. Now we can do C out and say enter your score. And then C in score. Okay. Now the pseudocode actually looks really much the same as what our code's going to look like, except for parentheses around our conditions. And then the print, we don't use print, we use C out. And so that should be pretty similar. So you should be able to just go through and kind of fill this out since I did use the same name. And so just do a C out instead of a print. And you can just print A, that's fine. And then make sure you use else if for each of the cases. B. And then just go down through, go ahead through those. You want to copy and paste. It might be a little quicker. And then else. Did everybody get that? If you have that, go ahead and test it and put in a score. Try doing different scores. Try doing an F, try doing a C, try doing an A. Always test it a couple different times with different data to make sure that it works for your different situations. So let's run it. Okay. A the first time. F the second time. We're trying it with different values, making sure they all work. Do all of your different scores work? Okay. Now, what happens if I accidentally enter 500 as a score? What letter grade do you think 500 will be? A. Okay. Well, that would be an A, I guess, if you got a 500. But that's probably way more than we would ever have on a test, and maybe that's an accident. That might have been supposed to be a 50, not a 500. And that would throw the grade book way up. So we need to make sure that we validate. And so this is great, but we probably shouldn't have scores of 500 in there, right? So we can validate that so many different ways, okay? So we have this range up here, okay? Now, you can go and add a range to each one of those. You can say that it's between 90 and 100, and it's between 80 and 90. We can go through and put ranges on all of those, but that's a lot of work. That's fine. We could do that. Or, we could just add another if at the top that says, right, what would be invalid, do you think? For higher grades. What would make it invalid?
The most I've been able to get from one test was 117.
Oh, it didn't do it?
No, that's
Oh, you mean like when you took test? Okay,
Yeah.
Yeah, you never know, there's extra credit.
20.
Yeah, okay. Yeah, we could do that. We could say that anything over 120 is invalid, because sometimes there's extra credit. You're right. Yeah, there's extra credit sometimes. So we'll go with 120. So we'll say anything greater than 120 or anything greater than equal to. You want to include 120? It really depends, right? So we'll do anything greater than 120. Does that sound good to everybody? In case there's extra credit. That's a lot of extra credit, by the way. So how can we add that? We can just add another if up here that says if the score is greater than, no, we'll say greater than, not greater than equal to 120. That doesn't include 120. Okay, now, and that would be invalid. I was talking about before, we don't want those separate ifs, right? So what I would do in this case is change that 90 criteria to be an else if. So it matches this. So if this is not true, then making this an else if will go down to test that one, and it's part of the overall grades. Does that work for everybody? That makes sense? Easy fix? Okay. So all we do is go up here, make this an else if. And we always have to start with an if. We can't start with an else if or an else. So score is greater than 120. We'll say invalid. Okay, go ahead and run it and try and put a score in there. That's 100, 500 again, do 500. Okay, that's invalid. You can't get 500. Everybody follow that so far? Okay. What if you get a negative score? What happens if I accidentally type in negative 50 instead of 50? Well, that would actually, let's do negative 90. Because it's supposed to be 90, but let's say I do negative 90. It's 50 still an F. Okay. That's supposed to be an A though, because that was supposed to be 90, but I accidentally typed in negative. Let's tell someone, instead of telling them based on the criteria for being a negative number, let's tell them that's invalid. So they know that's not really something you can. I don't think you can get negative on tests, but at least most tests you can't get negative. So we are gonna say anything that's a negative number is invalid. Okay. So down here where I have this part that is focusing on the else, I would need to modify that. And so I have a couple ways I can do that. I can just add, just like I was doing the criteria before with the greater than, we can just add an else if for the F instead. Make this like an else if score. What do you need this to be? Score is what for an F? Greater than equal to 0, yeah. Because then everything else will be invalid, okay? So then I can put my else on there and say that everything else invalid. Okay, So then once I have the pseudocode, I like to modify and think about the pseudocode first, and then we can modify the code. Although this really does look like the code in this particular case. I can just then easily go change this to score is greater than. Easier to change pseudocode than to change code. So if you make a mistake thinking about it, you can rethink your pseudocode. Although sometimes you get in there and find out that it doesn't work anyways, but we try our best to write the pseudocode before we do the code so that we can cause the least amount of problems as possible. Okay, so that looks like it matches my pseudocode. It makes sense, hopefully. Does that make sense to everybody? Okay, let's see if it works. What happens when I get a negative number in there? Let's see, negative 90. Okay, invalid. So it's telling someone you may have accidentally entered a negative number because that's not really a valid score instead of giving them an F. But I can still get an F. So if I do 0, then I still get an F. But if I do a negative, I get invalid. If I do a number that's way too high, I get invalid. Does everybody see that? That makes sense? Okay. There are so many different ways to do this. This is not the only way to think about this. I could have started with F and worked my way down, and that would be fine. You either start with the lowest or the highest. It doesn't make sense to start in the middle though. Because if I would start with like greater than equal to 70, that would cause a problem because that would also match B and A. Like if I started with C. And so if I said greater than equal to 70 is a C right off the bat, that would mess up my A's and B's. And it wouldn't make sense to start in the middle of the list of things I have. So you could start at the top or start at the bottom, and both ways would work. You can also, if you wanted to, you could think of it about it where you just clear up the invalid first, and then everything else would be valid. So I could restructure this so that I said, basically, if it's between 0 and 100, then it's valid, okay? So let me show you what that looks like. If you have this and you like it this way, go ahead and copy this code into here and save it. So you know you have something working, right? And then I want to show you some other ways of doing it, just so you can reason it but different ways, because I think the more ways you see it, the better. And we can talk about also, we haven't done between. And so I'd like to do between. So if we want to clear up all scores that are valid first, we can do a between. We can say that if the score is greater than equal to 0, because that would be valid, right? Now, how do we do between? We can't say the word between. Does anybody remember how to do between? What symbol they use for that?
That's the bars.
Close, that's the or. So it's a symbol we use all the time. It means and.
Oh.
Ampersand, so, ampersand, yes. Okay, so and. Okay, so if a score is greater than equal to 0 and a score is less than equal to 120, that's what we went as our upper bounds. Then, now, we are going to put curly braces this time, okay? So we're going to say that what's included in here, I'm going to put a curly brace here, and I'm going to take all of this and indent it and hit tab. And then I'm going to put a curly brace down here so that this is from here to here. And you don't have to do this. You can just watch if you want, unless you want to adjust your code if you like this better. So, or you can do both and copy both options. So if a score is between 0 and 120, including 0 and 120, that's what this is saying. Now there is the option of or, but or means that it is not included. So or can open up the range of anything, because or means that it just has to match one side. So if it's less than negative, or if it's less than 120 or equal to it, or would mean that it could be negative 1,000, because that matches the one side. Or it can be 500. That matches the other side. So if we want it to be between those two numbers, like if it has to be this side and this side, if both sides have to be true, if both sides have to match and be true, that's an and or only one side has to match to be true. So remember the other day I told you, think about and or. If someone tells you in everyday life to do this and this, you have to do both things, right? They're saying you have to do this and this. They both have to be true. If they say do this or this, only one of them has to be true for it to be true. So if I open that up to an or, if I put the straight up and down lines there instead of an and, that would be any number that exists, okay? So ors are great for invalid, which I can do in just a second to show you the invalid. But this really, and I'm going to put a little comment here, I want this to represent valid scores. So this means between those two numbers is a valid score. Does that make sense to everybody? So these are all my valid scores, and I need to take this off of here because that's invalid, okay? Then what do we do if it's an invalid? We can do an else and do invalid down below, right? So we can do else. And I can put the curly braces just to continue because I had curly braces up there. And this is where I can print invalid. So I'm handling valid and then I'm handling invalid, okay? That's one way to do it. Okay, and I need to make sure it works. So if it's out of range, oops, what did I do? Let's see. Oh, I need to make this start with an if. Okay. Always good to test, right? Okay, so if my score is way out of range, invalid. If my score is way out of range the other way, invalid. What if my score is in range? Let's try a number that's in range. That still works, okay? So that's another way to think about it. What if I handle all the ones that are in range and then the ones that are out of range would be my else? Does this way make sense to everybody? And this other way I'm going to show you is not the only other way to do it, but this is another way. You can also think of it like, what if I just handle all the invalid ones first as my first option? What if I just get invalid out of the way? That's an option too. So if I wanted to do that, what I would do, and this is called a nested if because it's inside the other if. So let's take it that logic. I'm going to step this back. Oops, I don't know if I can. Yeah, that's okay. Okay, so we are going to just take this over here, and I'm going to make this an else if again. And this way I'm going to handle invalid scores. So I would do, this is going to do all invalid scores. So how do I know if a number is invalid? If it's less than 0, right? Or, is this show up in outlines? Or if it's greater than 120. So these are two opposite numbers, okay? So we have the range of numbers on this side and the range on this side, but they are opposite, so we use or, because if it's opposite, it's or. If it's a range, you use and. Okay? So we handle it with or if it's opposites and if it's a range. So this is another way of thinking about it. So what I do in here, I need to actually put what I want to do. Invalid. Okay? So I'm handling invalid with the first condition, and then I'm doing all the rest. Now, technically, I could leave this as an else, but it's not hurting anything like that as an else if. So that's fine. So there's just so many different ways that you can do this. And I want you to know that just because you think about it differently and handle it a different way doesn't mean that that way is incorrect. It's just that everybody thinks differently. And so you may think of a different way to handle something than I do, and that's okay. And a lot of times I'll try to show you different ways to do it. But there are other ways to do this besides the 3 ways that I showed you, but just one of those ways makes sense. And you may say, oh, I like this one better. If I like the first one or the second one or the third one, or I thought of my own way, that's okay. Just make sure if you think of your own way, you test it and make sure it works. So if you want to write down all 3 ways or just one of the ways that you like, that's fine. We just have to think about how do we handle things differently. And I don't really have to put a range on all of those because I did the else ifs, but if I did them as separate ifs, I would need to put ranges on it. I would need to say it's between 90 and 100 and it's between 80 and 90. Okay. Anybody have any questions about this? Okay. All right. The next one that I want to show you, I actually have done for you. And so I am going to just copy it in here for you. And you can copy those in there for you if you want. This is the health program. It's called Health Membership, and it's on Canvas. You can download it. It's in a chapter 4 folder. So this is a lot of typing. So I didn't want you to have to type all that. So You can just copy it in there and test it out, and we're going to talk about it. So you have it, and again, on Canvas, so you don't have to type it in. So basically, I wanted to talk about this program with you. This program has a menu, and it has 3 different types of memberships: a standard membership, a child membership, and a senior citizen membership. So you pick which one you want on the menu. So you'll enter a 1, 2, or 3. If you want to quit the program, you'll enter a 4. Okay. And so this just displays the menu. These constant variables up here are there for the price. And so like an adult membership is the most expensive, and then a senior, then a child. And so depending on which option you pick, that's what price you'll be charged. And so in the actual calculations, instead of using these numbers, we use these constants in the calculations so that if we ever want to go change these, it's easier to change them up here than it is to try to find them in all your equations down below. And so I'll show you that in just a second. Okay, so then it's going to ask you, how many months did you want the membership? Okay, and that'll be saved in a months variable. So your choice of the menu is here, and the choice variable and the number of months is in the months variable. Okay, then if I look down here, if you enter a 1, so remember, if choice equal 1, then it's going to take, the equation is to take the number of months you entered times the adult price. Remember, the adult price is up here is 40. Now, I could have just put a 40 down here in place of adult, but the reason why I didn't do that is because if I decide to go up the price to 42, I may forget to put it in a spot down there. It's easier up at the top if they're all together, especially if you're going to use it multiple times, which I'm not in this program, but just in general, if you're going to have something that has a cost, if you put a constant variable at the top, it's easier to change that at the top than all throughout your program. And so it's not required. You could have put 40 here, but I think it makes it easier to see that way. Okay, so it's going to multiply and print. Now, this is going to give me 2 decimal places for all of my printouts. And so if you do that ahead of time, you'll get the 2 decimal places. If you don't choose choice 1, it's going to check to see if you chose choice 2. Now, for this program, we need to have curly braces because we have more than one statement inside of our conditionals. So for like choice 1, you can see there's two statements. So I need to have the curly braces. And for choice 2, and then we have choice 3 and choice 4. Choice 4 was ending the program, so it doesn't do the charges and the printout. Does that make sense to everybody? What if you don't enter choice 1 through 4? Then it'll say it's invalid. Now, we haven't talked about looping, so it'll tell you that it's invalid, but it doesn't do it again. Like, it doesn't repeat it. We will eventually talk about how to repeat it, and so we don't have to run the program again. But in the case that you enter something invalid at this stage, we have to run the program again, unfortunately, to get it to do something. So if I run it, I'm going to see, what's my choice? So I can enter 1, for example. How many months? We'll say 6 months. And it's going to give me the cost for that. Okay. What happens if I enter senior citizen for 3 months? What if I enter 4? 4 means quit. And actually, one of the problems with this, the way I did it, is I tried, and I don't know if I like it. I tried to not have this repeated in every single case, but did you see what happened when I entered a 4? I wanted to quit, but then it still asked me how many months. And so I have a couple of different ways I can solve this. I can either repeat the same thing in each one of these to ask them how many months, which I thought looked kind of funky, especially if I had more than the 3 choices. Or I can just see if I could put like a little if statement in here. If choice equal 4, or if choice equal 1, actually, or choice equal 2, or why can't I use and here? Because that would mean it would have to be all 3 at the same time, right? Now, whatever way you think, whoops, of handling this, or you can say choice does not equal 4 or something. If you want to do opposite. Did you have a question? Yeah, the not, yeah. If you feel like you're entering a bunch of things, you might reverse your logic and say the other way, like not, yeah, not that. Okay, so if choice equals 1, 2, or 3, and you can't do and because you can't be all of them at the same time, then I can ask them how many months. Now, it's not imperative that I do this. I mean, it's just another question, but it's kind of confusing because I said I wanted to quit and it's asking me how many months. And so I don't really like that. And so that should fix my problem. Or I could just add how many months for each of the different options. But I didn't like that either. So if I do 4, now it should say program ending. It doesn't give me the option of how many months, but let's just make sure that it still works for the other ones. Let's say I didn't do child membership yet. Let's do child membership for 13 months. Okay. So it still works for the other one. So there's a number of different ways of handling it. The problem is that this shouldn't be asked if you're wanting to quit the program. And so you can either put it in all the different choices down here, or you can tell it to only do it when it's the first 3 choices, or you can say if it's not the 4th choice. Does that make sense, everybody? I have the same problem. You might say, down here, you can see that you're doing the same line over and over again for each of the different choices. But the problem is if I put it outside of the conditionals at the end, it'll do it for the program quitting one, and it looks weird because it won't have a charge because you told it to end. So it's the same thing. If you wanted to put that if statement, you could do that at the end too and do the total charges. It depends on if you think that that's repetitive and annoying, you could do that if you want to. So does everybody understand this program? Okay, I didn't want you to have to type all that, so that's why I gave you that one. So make sure, did everybody find the program?